habitat and white salmon in part of Skamania County. We're part of a statewide network of regional fisheries enhancement groups, and we are an independent 501c3 governed by a board of directors. So I want to take a minute to thank and acknowledge the directors who are on the call right now. I see Dave. Dave, do you want to turn on your camera and wave? Not only a director for Mid-Columbia Fisheries, but also one of our most dedicated volunteers. All right, well, you'll have to trust me that he's here. I'd also like to introduce...
Apparently I can't get my video to go.
Oh, that might be a permission that let's see.
Oh, Catherine is telling us none of them can turn on their cameras.
All right, try now, Dave. I think I changed the permission.
There we go. Hi.
Okay. Yeah, thanks for directing us, and thanks for being here. Cindy is here as well. Cindy, do you want to say hi? Oh, thanks for bearing with us on our first one of the season while we're figuring out this part of the technology. I'd like to also introduce our director, Margaret Newman.
Hi, everyone. We're glad you're here.
Our outreach coordinator, Merritt Mitchell.
Hi, everybody. So exciting to see everybody, and we're excited to share Kat's great presentation.
And as I said, this is, and Kat Strathmann is our presenter, and she gets a more thorough introduction in a minute or so. So you can just say hi real fast now, Kat.
Good evening and hello. Thanks for coming out.
So we hope that you will be so excited about this one, which I personally am very excited about, that you'll also join us on February 5th to learn about bull trout protection, on February 19th to learn about actions to improve fish habitat in the Middle Columbia River, and then on March 5th for the rescheduled Waders to Weed Management about the Careers in Conservation Summer Program that we've been excited to plan with some of our partners. Those registrations are all on the same Eventbrite page that you used to register for this. So Bill, please sign up and join us. Okay, well, let's get started. So Kat's going to talk with us tonight about what it takes planning for riparian restoration. And she's really the right person for the talk. She's the most conscientious, thoughtful, big picture professional I work with. And it's been such an honor for 11 years now to be her coworker at Mid-Columbia Fisheries, because every project with which she's involved is done with intention, with a commitment to quality, and with an absolute dedication to success. And that comes from the fact that she's bringing 27 years of experience, and she works with a goal to apply scientific knowledge to planning and then conscientiously evaluate her outcomes. She describes her current passion as being the intertwined fluvial and biological processes that create and sustain riparian forests. Before she worked with Mid-Columbia Fisheries, she was at the Yakima Nation, and prior to that with the Park Service. She has a master's degree in ecology and systematic biology from San Francisco State University, and she's just really a lot of fun to learn from. So Kat, please teach us what you know.
Well, that was super nice, Becca. Thank you. And I'm so excited to talk to you all this evening. So thanks for coming out. I'm excited to talk about one of my favorite topics, whether it's at work or not. So I'm going to share my screen, and I'm going to go off camera while I'm presenting tonight. And then, oops, that's not going to work. And then I will come back at the end. So here we go. And let me know when you can see what I put together for you. Okay, is that working?
Looks great.
Wonderful.
Kat, I forgot to mention that folks could be putting questions in the chat as you go. And then, as you said, when you're ready for your questions at the end of the talk, we'll unmute folks and be ready to have both a chat and a voice discussion.
Great. Okay, let's see. All right, here we go. So, thank you. Before I get started, I just wanted to give a couple of shout outs for thank yous. First, to the many funders that we have for our riparian projects, much coming from the Department of Ecology's Water Quality Program, the Salmon Recovery Funding Board, the Washington State Conservation Commission, and the Fish and Wildlife Partners for Wildlife program. So very fortunate that that we have a lot of support for the riparian work that we do. And none of this could get done without the many partners of Mid-Columbia and many Mid-Columbia staff. Most of the folks that have helped to get these things on the ground are not even on this call today. So we couldn't, there's many hands involved, and just really, really grateful to each of them. So what I'm going to talk about tonight is giving you a little under the hood look at riparian restoration and hoping to answer some questions about why and how we do what we do. The photo that I'm showing you right now is one that I'm borrowing from Kittitas County. It's lovely. I adore it for a number of reasons. In addition to seeing beautiful riparian forest in the lower, and the Yakima River in the lower Kittitas Valley, it illustrates a few different things. One is on this meander bend, we have naturally establishing riparian forest, cottonwood, black cottonwood forests, and willows that are in great shape, lots of different age classes. Right across the river, we have some plantings that were done a few years ago that are starting to mature. There are also some trees that I have had the good fortune to watch grow from the time that they were small saplings in a reed canary grass field. So, and then peeking out over, I don't know if you all can see my cursor, but peeking out over in the upper right of the photograph are some other plantings, 4 acres of plantings that we did in this area. So it shows a whole lot of things that are pretty neat about this riparian restoration that we're talking about tonight. So again, thanks Kittitas County for letting me borrow your drone image. So I'm going to jump right in because I have a lot of things that I want to talk to you about. But the first thing that I wanted to talk about is that we start every project really defining what we're trying to accomplish at a project site with riparian. So what are those functional goals that we want to see? What's missing from the site? Is it floodplain roughness, meaning being able to slow down water and capture sediment? Is it canopy that's keeping cool water cool, isn't there? Or do we have a lot of bank erosion? And because our rooting density is gone, trees are gone, shrubs are gone. So we want to slow erosion. Or do we need like this photograph from an Idaho river, the Big Wood River? Do we need to develop a source of large wood over the long term so that we can maintain this channel complexity process? And then, of course, in this era of changing climate, we know that our riparian areas are really important habitat corridors, and it's even more important with higher temperatures. Okay, so that's where we start. We also look at site conditions. We're going to hear a lot more about these as we move on. So I'll just touch on the general site conditions that we think about. We work across 4 counties. And so the precipitation zone ranges from 6 to 30 or 40 inches of elevation or more. Actually, I have the upper end wrong, but we generally are not doing riparian restoration in those higher elevations. We also look at depth to groundwater. We look at soil texture in terms of moisture retention, how flooding is happening, We look at current vegetation conditions, whether it's weed pressure that happens to be present, or what the vegetation is telling us about the history of the site, or propagule availability, and then herbivory. So there are a whole bunch of different things that we look at, but these are really the key conditions that we're looking at, no matter what type of riparian restoration site is involved. Okay, so there are a lot of different approaches to riparian restoration. So I wanted to give you kind of a framework of how to think about the riparian restoration is more than just planting. So it's really a way of thinking about and approaching riparian and floodplain habitats. So these first two approaches are really things that we can think about during planning of construction, or what we think of as engineering design, when we're getting ready for a construction project and planning those designs. So these first two I'm going to talk about in terms of how we can develop those conditions ourselves using construction. And then I'm going to wrap up with kind of some of the actual planting and putting plant material in unvegetated areas. So another way of thinking about approaches is this table that I put together a few years ago that illustrates or articulates methods that are fairly, I won't necessarily say completely low effort, but they don't require planting at all, like fencing to reduce herbivory, all the way up through super high in effort involvement of managed flows, which require like stakeholder involvement and working on environmental flows of regulated streams or rivers. So the things that we're going to be talking about tonight are in this middle zone, and those closer to the bottom involve our construction design. So they're things where we can help to make revegetation and natural regeneration more successful. And then these are more our revegetation of actually installing plant material towards the top. So these are the ones that we'll be covering tonight with these general approaches. And regardless of what approach we're using, there's a general timeline that I have found is going to be true regardless. And sometimes we need to truncate it because of funding that's available. But really, to get things to set our riparian restoration on a successful trajectory, this is what we found works. So we're going to talk about starting with construction design. Site preparation starts, and we're ordering plant material before we've even put that plant material in the ground in what's usually year 2. So they're thinking about what that riparian restoration is this right here. It's planting. We also will talk about these temporary herbivory deterrent fences that we can use, and if that's an issue, temporary irrigation and weed control. So as you can see, riparian restoration is quite a commitment. So as Becca said, really making sure that we have our ducks in a row, that we know what we're doing and we're doing the thing that's going to be the most successful is really important when we're talking about this kind of commitment. Okay, so let's start by talking about this first approach of what we can do when we're in a design phase of a restoration project, and we can create conditions for natural regeneration. So let's look at what that really means. So I want to back up for just a minute and talk about one of my favorite riparian species, black cottonwood, but also its cousins, willows. So cottonwood is the dominant tree species in the arid West, floodplain and riparian environment. And willows are also one of the dominant shrub species, and that is across most elevations until you get to the highest elevations. So in the lowland floodplains in particular, where we do most of our work at middle and low elevations, these are key species. They're also in the same family and have very similar regeneration or sexual propagation uh, uh, characteristics. So, given that, there are several conditions that are required for a cottonwood or riparian forest regeneration. The first is that floodplains have to be connected to the river. The second is that so that means that we need floodplains that are functional, water getting out onto the floodplain. So there can't be constrictions or structures that are preventing that. We also need the bare substrate. And in this stylized hydrograph, which is called by Stella the recruitment box model, this hydrograph and the peak of this hydrograph is representing significant habitat forming flows that create that bare substrate. And that's where we have seedling generation. So we also need moist soil at the time of seed release, and that's illustrated. The time of seed release and the recruitment box is this stippled box here. So we need moist soil, which happens because of the spring freshet, the snowmelt peak that is higher than low flow, than summer flow, and it moistens up those bare substrates. Seed lands on them and germinates. And then those seedlings also need to be able to survive summer drought. And that happens when the flow recession rate, or this declining limb of the spring freshet, doesn't exceed the rate of root growth, which is 1 to 2 centimeters a day. Okay, so that's a lot. I want to kind of go back to a couple of things and how this ties specifically to our engineering designs, or designing a floodplain or channel reconnection or channel reconfiguration project. So one thing that we wanted to know in a recent design project is what the ground surface elevations were at the spring freshet, so that we could figure out what those spring freshet flows are, when were cottonwoods getting established, and what are those target elevations that we should be setting in design, and what are those flow return intervals, the flood return intervals for the spring freshet. So what we did is excavated some seedlings here. I did this with Stephen Yurikawa, who's our Riparian project manager. And as you know, seed cottonwood and willow and other riparian species are really cool and important because they provide roughness. And that means that as water slows down, sediment is dropping out and aggrading. So the soil surface that we see at present is not the soil surface of establishment. And so what we were able to do is survey in, excavate out, and then survey in what that elevation was at the time of establishment. And knowing that there was a successful establishment year in 2017. So we developed what these successful estimated elevations were, and then those corresponded to a 1.5 year return interval, which interestingly was also what we saw in the 2017 spring freshet hydrograph. So this is from Umtanem, which is the water data that we use in the lower Kittitas Valley. And from 2017, we can see that we had a freshet that was about 6,000 CFS. So at this point, 1.5 years corresponds to 6,000 CFS. And and wetted up those surfaces that then were not exceeded by the summer flow. So, any rate, pretty cool. Getting into the weeds, but really important when we're thinking about how to design these projects. So, how just kind of tying this all together for you that aren't in the weeds with engineers and hydrologists. What this means is that we can target groundwater. We can target ground surface elevations that provide us shallow groundwater, and cottonwood require groundwater, and willow and many riparian species that is essentially less than 6 foot from the soil surface. So we can set grading elevations for that. We can also set flood frequency return intervals for how we grade floodplains to that 1 to 2 year return interval. One thing that I wanted to add is that we also need to evaluate, as the riparian ecologist, we need to evaluate what propagule sources are nearby, because this kind of work of regeneration is not going to work unless we have the seed sources upwind somewhere of our project sites. So one thing that's pretty neat about this, bringing this all together, is that we have seen this happen on a project where we actually accidentally at the Reeser Creek floodplain set low elevations that were graded at low, essentially shallow groundwater, created these seedbed surfaces that were then moistened up by the spring freshet at seed release. And we had a lot of cottonwood and willow in the vicinity. And now we have this really amazing initiated cottonwood and willow, mixed willow acreage at the lower part of our floodplain. So we know that this can happen naturally, accidentally, and we can also target it in our restoration projects. We are also developing a pilot project to use agricultural tilling and irrigation to create an irrigated seedbed, and we're initiating that. We've been working on it for about 1.5 years, and so that is going to be moist, bare soil that will be wetted up in the spring of 25. So I'm pretty excited for that project. Okay, so I wanted to now jump into a few other things still in the design world, still thinking about what we can do to create these conditions for successful revegetation, meaning when we are adding plant material, what can we do in the design phase to make that adding ourselves, not the natural regeneration, which is the best of all possible worlds, but what can we do to make revegetation more successful? And there are a few things that we know. So as I said, groundwater that is within 6 feet from the ground surface is required for these hydrophytic species, meaning that they're water loving. They need to be connected to groundwater. But an ideal depth is really more like 1 to 3 feet. And we'll see that in terms of planting methods in just a minute. We can grade banks so that they're much more gentle. This not only increases the area of inundation and creates more wetlands, but also increases areas of natural regeneration. And then we have greater areas with shallower groundwater depths that are going to be easier to revegetate. And then finally, one thing that is another way of creating more space for replanting is creating floodplain depressions or swales that perhaps are not immediately adjacent. We want vegetation that's not necessarily immediately adjacent to a channel, but back on the floodplain. And this is one way of getting lower, shallower depths to groundwater. Okay, so we can also integrate riparian into constructed features. I'm not going to talk too much about this. This is an example of an engineered log jam in the Tianaway in one of Becca's projects. But thinking really clearly about what do we want to get out of these features and what can vegetation do to help extend the lifespan or the function of those features, so that in 30 or 50 years, once those features degrade, if we still want function, what is it that we should be planting now? So there are a lot of different things in play here. How can we incorporate it, riparian plant material, into the features? Will sediment and vegetation communities respond to the features in terms of aggradation and developing communities or erosion? So we don't want to be planting, but a lot of things in consideration there. Something that we are working on, and then another piece of in this design world is thinking about access and playing out, for example, in this design drawing of cut fill areas, what is going to be inaccessible if we're creating channels or connecting channels? Are we going to be left with areas like this between two channels that are going to be very hard to revegetate? If they're a priority area to have some of those floodplain functions, then we need to think about our sequencing and get in early before the second channel is constructed. So a lot of sequencing ideas that we can work on now. Okay, I want to jump into replanting, because that's probably something that you guys were excited about. When people think about riparian restoration, we go right there. So I'm going to jump right in and probably give you more than you ever wanted to know. As I said in the beginning, there are some key conditions that we think about. And I tried to give you a breakdown of how we think about these key conditions. So groundwater, these riparian plants are really controlled by groundwater and surface water, and that makes sense because that's inherent in the name in riparian and riparia. So what we know has worked is that when we have shallow groundwater, we can plant conventionally. However, when we have moderate or deeper groundwater, moderately deep or deeper groundwater, then conventional planting likely is going to or will actually require irrigation. And our plant assemblages that we can use will change. The deeper the groundwater is, another technique that we use called deep planting that I'll be talking about in a few minutes, can be used, but then that is a smaller subset of species. So there are some neat things that we can do with that, but the drawback is species diversity. So again, if we're thinking about function, it's important to think about what functions we're getting, even if the species diversity may be more limited. And then once we're in situations where groundwater is deeper than 6 or 7 feet, then conventional planting is really all that we're left with. That does require irrigation to be successful. And we can't really plant those hydrophytic species anymore. So trying to give you an overview of how these things are linked and why we might choose a particular method or methods, why we might choose conventional planting plus irrigation and specific species. Okay, another thing that we think about is how long a site might be inundated. If it's inundated for more than 4 weeks or so, then there are specific species that are going to be the most water tolerant. So not every species can handle being inundated. That means that they need specialized structures to be able to breathe through roots and bark, and not every species has that specific physiology. So if inundation occurs, but on a shorter duration, then we have a lot more species that we can use, including cottonwood. So cottonwood is not one of the species that can deal with long duration inundation. And then completely intolerant of inundation are going to be our dry forest species and shrub steppe species. So thinking about what's getting water and for how long is pretty important. We also want to think about velocities. This is an example of a plant protection structure that we piloted down in the lower Yakima River, where winter velocities can be pretty high. And we did not want new plantings to get sheared off by material that was like logs like these that were traveling across the top of the site. So thinking about how to deal with velocities, whether you're talking about bank erosion or you're on a lower elevation meander bend like this, is important. We also think about what other critters might be in the environment. And native critters. So if we're dealing with elk and deer, we have used temporary fences like this one that's up west of Cle Elum. And we keep those fences up until the plants are at or getting close to or exceeding the level of browse of deer or elk. So once that apical meristem is up above the browse line, then we're not as worried about either plants getting hedged or and then eventually becoming less vigorous. So if we have beaver activity, then we're really interested in getting roots developed. We know that beaver are an important part of floodplain and riverine environments, and so what we're really trying to do is get these roots established over a couple of years, and then remove the fencing, and they should be able to, especially these mesic species, will be able to resprout. So these are how we deal with native herbivory, and then livestock fencing is permanent if livestock are a permanent feature of a private landowner's property. Okay, we also think about weeds and vegetation, and what I want to emphasize here is that the initial condition of the weeds, whether it's a bare soil constructed floodplain or a fairly recently managed pasture or field that's pretty clean, down to maybe a very old pasture that's pretty heavy with weeds and even reed canary grass, all of these things are going to affect the level of site preparation that's needed, the number of years or seasons of site preparation, which could range from don't need any. Immediately post-construction, we can do what we need to do with putting plant material into a site. But we may need up to 2 years of persistent weed control. The planting method can vary, does not vary with the exception of reed canary grass. So we only use the deep planting method in reed canary grass because of the tall plants that we use. And I'll be showing you that in just a minute. So you'll be able to envision how these plants can be competitive with 6-foot tall reed canary. And then the weed condition at the beginning of the project is definitely going to affect what we anticipate in terms of post-planting maintenance. The weedier it is at the beginning, the more work we're going to be doing afterwards. Okay, because of what's in the seed seed bank, excuse me. Okay. So you've seen me refer to these different plant assemblages, and I just wanted to give you a tiny flavor of what that is. So again, forested wetland are these hydrophytic species, different groups that are used in conventional planting versus deep planting, and these are all adventitious rooters, which we'll see in a sec. Mesic riparian are those which are less hydrophytic, and more tolerant of a wider range of hydrologic conditions. Mixed riparian is more dry transitional species, and then dryland forest species. So again, deep planting is the same suite of species that have these particular characteristics that make them successful. Okay, so now we finally get to talk about deep planting. What is this? So deep planting is a technique that we use when soil moisture is usually between about 3 and 6 foot depth, and using tall plant material. In this example, we are using a skid steer mounted auger down in the lower Yakima River to reach groundwater. So we're placing roots of tall plants into moist soil. We can do that also with a hydraulic ram. This piece of equipment is owned by Wildlands, and they were putting plants in for us at Spring Creek in the Kittitas Valley. This steel shank is about 6 feet long, and it pushes into the ground and drops these plants that are 6 to 10 feet tall into the hole that's created, so that the roots are in moist soil. So irrigation is not necessary. Here's another project that we just did. This is again down in the lower Yakima, using the hydraulic ram. So whether we're using an auger or a hydraulic ram, we need to backfill those holes that were created and make sure that we have really good soil contact along the stem, so that they can root. So that when I talk about tall plants, those are these 5 to 10 foot tall stems that you can see here on top of a 10 to 14 inch root mass. And when they're planted, the root mass is going down in moist soil, and we leave at least a foot or roughly 5 live leaf nodes above ground for photosynthesis the following spring. We install them in the fall, and we use adventitious rooting species, which is a small suite of species. And that's adventitious roots are the roots that grow from parts of the plant that are not root tissue. So even kind of mangrove buttress roots fall into the adventitious root category. But some species, riparian species, are really adapted to create those that are in a flooding environment and that are adapted to the stress of seasonal inundation and seasonal sediment deposition. So their meristematic tissue gets stimulated to when buried and moist to create these roots. So that's what we're trying to do, is put them in the right environment and create roots. So I wanted to show you a recent project where we use this technique. This is also in the lower Kittitas Valley on private landowner. And the functional goals for this project were to slow down bank erosion. We had very little rooted woody vegetation here. And then also, because there are cattle that are grazed on adjacent properties, we wanted to really slow surface velocities, help sediment and fecal coliform drop out and be retained in the vegetation. So this is a site that is in a fairly low precip zone. It's a low terrace that had deep but not extremely deep groundwater, heavy cobble soils, and had a couple of low areas with a lot of reed canary grass. And as well as in addition to the cattle, we have some migratory elk that use the area a lot. So that's what we knew we were getting into. And what we did here in the reed canary grass, we started by treating these reed canary grass areas. So this is a meander bend at our project site. And then we used our deep planting method. We did not have a great logistical setup for irrigating, and we also did not want to have the long-term commitment to irrigation. And so we used the hydraulic ram to put plants in the ground. We also used a variable density planting where we planted this gold strip that's about 30 feet wide adjacent to the Yakima River side channel at high density of about 5 to 7 feet spacings, so that we really kickstarted that high rooting density to slow down erosion as quick as we could, and then had more standard 12-foot spacings away from the side channel. Because of those herbivores, both the cattle and the elk, we enclose the planting area with a permanent fence, and it's a tall fence. It's almost 8 feet to prevent deer. So we'll be taking the top portions off for long-term maintenance. So we've this project has only been in the ground for about 1.5 years. So our first year of survival monitoring showed that we had about 80% survival overall. And for the species that we used, we had pretty variable survival, with cottonwood and our willows responding most strongly and having lower survival of about 65-70%, of our alder, and a little almost 75% in the first year for red osier dogwood. So overall, doing pretty well. And we usually see heavy drop-offs in the first year, moderate drop-offs in the second year, and then sites tend to stabilize after that. Okay, so let's talk about conventional planting now. And that's the kind of planting that I think we all think about in our mind's eye when we think of riparian restoration. So putting things in the ground with the shovel. But we can also do this with a shallow auger. It doesn't have to be a shovel. We generally use mesic. We can use a wide variety, like of species types, depending on how shallow groundwater is and if we're able to irrigate, or if that is logistically something that we can or want to do. Like this, in this project that you're looking at on Wilson Creek, on these low terraces that were in reed canary grass, we were able to plant, and we actually planted live stakes without irrigation. And then we irrigated on top of the terrace that was 3 or 4 feet higher in elevation. So why would we irrigate? So for folks that are not from the east side, we have a very low precip zone in the counties that we work in. So in Benton and Lower Yakima County, we're 6 inches or less per year of precipitation. And most of our planting projects are within 6 to 20 inch precip zone. We also want to irrigate where groundwater is deeper than 2 to 3 foot depth, and we're not able to use deep planting. We irrigate primarily to really speed up fine root development, and that overall is going to increase our plant survival. So when we have fine root development, plants are more able to extract the available water, groundwater, from soils. Okay, so when we do irrigate, our approach is to irrigate for 1 or 2 seasons during the summer drought, and to use deep, infrequent watering. And that means applying 5 gallons of water per plant every 1 to 2 weeks. Usually in many projects, we start out watering once per week and then move to once every 2 weeks. And if you can envision a long cylinder of water that is a 5 gallon bucket that is stretched out so that it's reaching down into the soil 3 or 4 feet. That's really what we're trying to accomplish. And we do that primarily these days with drip irrigation. So one of the drawbacks of irrigating is that it does require water, right? And it also requires access to a water source. So that is not always feasible. And that may be why we choose deep planting. Okay, so I wanted to also focus on the different types of irrigation. And we have learned that drip irrigation is it's the most effective and the most cost effective. It gets plants watered deep as opposed to other methods that really provide top watering. They may only get the first few inches to foot or so of soil moist instead of really watering deep and trying to get those roots to chase the groundwater down. Because it's irrigating at a specific point, weed management implications are really almost negligible. That's probably somewhat true as well with handheld hoses, but broadcast irrigation, which is very cheap, creates a nightmare of additional costs trying to deal with uncovering your plants from a lot of weed growth. Installation costs are pretty low given the materials that are needed, and we're able to reuse pumps and reuse a lot of our line from year to year. And they're also incredibly low labor costs. We have one project site that is about 3.5 acres, and that project takes 1 to 2 people about a half day to a day to water, compared to if we were watering by hand, that would be a multi-day, all hands on deck project. Okay, so I'm going to wrap up talking about a conventional planting site that's just west of Cle Elum. And this project was initiated very similar to the other because we had an area of high bank erosion. And we also wanted to capture surface flow by creating more floodplain roughness, as well as additional bank shading that was closer to the 150 to 200 feet site potential tree height. So higher precipitation zone, very, very deep water on an elevated groundwater on an elevated terrace, a mix of fines and cobbles and moderate weeds, as well as a migrating elk herd that was identified by the landowner. So we chose at this project to use conventional planting of a mix of transitional shrubs and conifers, and we drip irrigated this. This is our drip irrigation that ran through all of our almost 9 acres of project area, over 4,000 plants. And we completed weed management until this last year. We're finally wrapping this project up after over 4 years. We installed a temporary elk fence that you can see here that enclosed the plantings, and that was removed last year. So pretty exciting that this project is really on its way to a handoff of successful plant growth. And as I said, there's usually at many sites, we see high plant survival in the initial year with irrigation or deep planting, and then a drop off. And the thing that's pretty great is that we are not seeing a really heavy drop off post removal of irrigation. So that's a great outcome. So I wanted to wrap up just reminding us of what this riparian restoration timeline takes. And And especially that we often think of riparian restoration as this thing right here, just the planting. But as I hope that you leave with something, it's understanding that there's a lot that can go into the project to make it successful before we even get the shovels out. And then after the shovels are put away or the heavy equipment is put away, then there's also a lot of work to get those plants successfully established. So it takes a lot, but we're very happy with a lot of the projects that we put in so far. And with that, I'm going to wrap up and say thank you so much for your attention, and just really excited to share this work that I'm so passionate about with you all.
Thanks so much, Kat. That was really well put together, really interesting, and really relevant to at least what I do a lot of the time, and hopefully to the other folks on the call as well. I'd like to open it up for questions, and I think the best way to do that is for you to raise your hand, which is on the bottom of your screen. There's a heart that says react. And if you click on that, it gives you the option to raise hand. Or you could put a question in the chat and I could call on you. Okay,
And
so
everybody should be able to unmute themselves at this point. So,
but don't all talk at once. So Cindy has a question. If riparian restoration isn't typically done in the upper elevations, what do we use as an indicator of where to start restoration? Is it elevation or a specific plant species assemblage or soil types or?
That's a great question. Typically, we're working on areas that are impacted in some way, whether it's a stream channel or a floodplain that has been altered by timber harvest or by levee building. And so Becca and her team are designing construction projects to eliminate those levees or recontour or regrade floodplains. So that may determine why we're in a project area. Where I didn't include a slide, but I did want to talk to you about prioritizing riparian restoration. And we often are looking at those functions and what we're getting for fish in particular, and how it is associated with our mission. But we're really fortunate that a lot of the high elevations are just not as impacted as lower elevation agricultural or more developed areas.
Thanks, Kat. Other questions? If you have your hand raised and I'm missing it, then just unmute and speak up.
and I am searching through folks to see if anybody's hands are raised.
And Cindy asks, where do we usually get our restoration stock?
Well, that's a great question. We have about 4 nurseries that provide material that is local to our region, and so we typically will request. If we request our plant material at least a year ahead of time, then if they don't have the seed stock in-house, then they can collect that or purchase it. But we use the USDA's provisional seed zones that are based on elevation and aridity and temperature. So it's a good way of making sure that we're not selecting a genotype that's outside of the range of our target site. And actually, we assisted migration is a big topic in riparian or in all restoration, habitat restoration right now. And one thing that we do that's not necessarily assisted migration, but we will often select species from a seed zone that is lower in aridity or elevation from our target seed zone. So nice question. Thank you. And I'm happy to share those nurseries with you if you're interested.
And it looks like we have someone here from BFI, Catherine.
Yeah. Hi, Katie. Thanks for showing up.
Derek put in the chat that at Clark Public Utilities, the restoration projects are also supporting native pollinators in a big way.
Our partners for wildlife projects are big supporters of including pollinator habitat. So we actually are working with a private landowner who wanted to include specifically some shrub steppe areas that are going to up pollinator diversity. So in his floodplain, but at higher elevation. So it is pretty fun to be able to address those neat associations. However, I will say that willows have a lot of insect associations. So.
Kat, I had a question, which is that this is the first year we've really leaned into using wood chip mulch instead of plastic weed fabric in a large scale. And I wondered if you wanted to briefly speak to lessons learned on that and suggestions for other folks in future years, and maybe just why we've made that change.
Yeah, that's a really great question. So we wanted to move away from using landscape fabric as a weed suppression fabric, which is something that has been done in a lot of agencies for years, primarily because of the difficulty in removing that fabric and not having kind of legacy plastics in our soils and stream banks, essentially. So we looked at a number of possible plant-based materials, and wood chip mulch is just the easiest to come by, and it's still quite expensive. And so I think that the lesson learned that Becca is leading me to is that we really are moving towards purchasing our wood chip mulch in high volume and contracting it out. And that in that way, we were able to bring the cost down to something reasonable. But it actually still pencils out as being more expensive, unfortunately, even with the installation costs and removal costs of weed suppression fabric.
That was actually not a guided question, but it was still a great answer. I was just thinking that for other folks who are probably trying to reduce microplastic contribution to the ecosystems, they'll be thinking about what they need to know.
Mm-hmm.
We're 1 minute from our ending time. I see some thank yous from folks in the chat. Kat, it was really great. Oh, great. Martha, go ahead, please.
I just have a practical question because we've tried drip irrigation by pumping out of the creek, and it just clogs. It looked like you had miles of drip irrigation. So how do you keep it from clogging?
You know, I am probably strangely not the right person to answer that. There are 9 staff people on our restoration technician crew that is led by Aaron Balagat, and Carson Brisky has been installing our irrigation for quite some time. So we have some great staff that could answer that question. But I know that our first year of drip irrigation, which was out at the Cle Elum site, the last site that I showed you, we had a lot of lessons that we learned. So Martha, why don't you email me your question and I will make sure that you get an answer, because I really want to keep from reinventing the wheel, and I would love to help you do the same.
I do know they use big filters, right?
We use a lot of filters, yeah, and we also do we have a lot of processes for how to clean and maintain drip irrigation. So the person that's on site managing the drip irrigation is making sure that every emitter is working when they are doing a walkthrough during irrigation.
Mm-hmm. Okay, thanks.
Yep. Sorry, I couldn't answer that better.
Kat, that was fantastic. Thank you for your time. Thanks to all the folks who joined us. Great to have a good crowd. I put the link for the sign up for the upcoming talks in the chat. I encourage you to go ahead and register right now so you don't forget. And thank you again. Have a great night.
Thanks, Becca. Thanks, everyone. Have a wonderful evening.
Thanks for coming, everyone.